you've got a heat pump and you've been browsing YouTube for heat pump related videos, then you've probably stumbled across the heatpumpmonitor.org website. This is where a number of heat pump owners have publicly shared their heat pump performance data, so as you can see how efficient they are and how different brands perform compared to each other. My own system is on there too, and you can browse back through over a year of detailed data if you really wanted to. This is all running on a platform called Emoncms, which is part of the Open Energy Monitor ecosystem, and this video is a tutorial on how to configure Home Assistant to send your data to Emoncms and how to configure Emoncms to produce the fancy graphs. There's a lot to cover in this video, so let's get started. Emoncms is the software behind Heat Pump Monitor, and you have a choice to make. Do you want to use the cloud-based Emoncms.org solution and send your data there and let Open Energy Monitor host your monitoring solution? Or do you want to host Emoncms locally on your own home network and keep your data private? Using the cloud solution is probably the easiest option, and it also means you can easily share your data on the Heat Pump Monitor website too, and have your installation listed on their leaderboard. But it does come with a cost. Open Energy Monitor charges a small amount for each feed of data that you are monitoring. At the time of recording, this is only £1.20 per feed per year. A feed is something like the heat pump power or the energy or even the outdoor temperature. If you're showing a line on a graph, then that's a feed. In this example that I'm going to show you shortly, I'll be creating 10 feeds, so that would be £12 per year. But this whole tutorial assumes you already run Home Assistant locally, and if you're not interested in sharing your data publicly or just want to keep it private and local, then you can run Emoncms locally as an add-on in Home Assistant. This requires a bit more work, but it does avoid having to pay for the feed credits. There is a third scenario too, which is what I have set up, and that's if you want to keep all of your data locally but also share it publicly on Heat Pump Monitor. You can set up your local Emoncms instance to synchronize with Emoncms in the cloud, but you then do need to pay for the feed credits to do that too. The advantage is that if something ever happened to the cloud system, like they shut it down or something, then you still have your data locally and your monitoring will keep on running. So before we begin, you need to make sure that you have the required data in Home Assistant already. I'm not going to cover exactly how to do that in this video because it really depends on what brand of heat pump you have, or if you have a professional grade monitoring system installed. Open Energy Monitor sell professional grade kit which monitors the energy used by your heat pump and the heat energy it generates very accurately, but it's quite costly and requires a heating engineer to install it. The kit does come with Emoncms anyway, so if you've gone down the route of a professional solution, then you probably don't need this tutorial anyway. If you've got an Octopus Cozy heat pump, then most of the data you need is provided by the Octopus API, and you can get this very easily by installing and configuring BottleCap Dave's Octopus Energy integration. I've got a Daikin heat pump, and unfortunately it doesn't provide you with the data you need out of the box, but I've installed a little device called ESP Altherma that wires into a serial port inside my heat pump and sends data over Wi-Fi to Home Assistant. And then to get power and energy data, I've used a Shelly Pro EM which has a CT clamp around the live feed to the heat pump so as it can track its consumption. So what data do you specifically need for Emoncms to work then? Well, at a basic level, you need to provide it with energy in, so the electrical energy that your heat pump consumed, and you need to keep track of the heat energy out. Those two values will allow Emoncms to display your energy usage graphs over a chosen time period and also calculate your COP or SCOP, which is your efficiency. Both of those energy values need to be in units of kilowatt hours and they must be cumulative, so they shouldn't ever reset to zero. So a daily energy usage sensor is no good. Use one that keeps on increasing forever. Now if, like me, your heat pump doesn't provide you with the heat energy out data, then you can calculate it. But to do that, you first need other data points. Firstly, you need to know the flow speed of the water through your system, and this must be in litres per minute. Then you need to know the temperature of the water coming into the heat pump, also known as the return temperature, and this should be in degrees Celsius. Lastly, you'll need the temperature of the water leaving the heat pump, called the flow temperature, and this should also be in degrees Celsius. You'll then probably want to display the power consumption of your heat pump too. I get this from my Shelly EM, and the value must be in watts, not kilowatts. If you have a sensor in kilowatts, then you'll need to convert it to watts first. You can display the heat power output too. Now the Octopus Cozy gives you this value in the API, but if you've had to calculate the heat energy output, then don't worry, Emoncms can output the heat power output too as part of that calculation, which I'll show you later on. You'll also want to monitor the target temperature. Now this can either be the target temperature of your room, so your set point in the house, or it can be the target flow temperature. I use the target flow temperature personally because that can vary due to weather compensation settings on the heat pump, and it's quite useful to see in the graphs how close the actual flow temperature is to the target temperature. You should probably monitor the outdoor temperature too, because that provides some context to the data on a particular day. You might see your energy use rise dramatically one day, for example, and knowing that it was due to it being very cold that day is an important detail. Ideally, you should also have a sensor that knows when the hot water cycle is running. This should be a binary sensor that turns on when the hot water cycle is running, but off at all other times. This will tell Emoncms how much energy was used to heat your hot water as opposed to heating your home, and it can then separate out the data and give you different COP values for hot water and heating too. And finally, you can send your room temperature over to Emoncms too if you want it to log that as well. This tutorial has a lot of information in it, so I've put timestamps down in the description so as you can skip to the steps relevant to you. Let's start off by making sure we can edit our Home Assistant configuration file. This tutorial is based around Home Assistant OS, which has an add-on store available full of extra components that you can install. If you're using a different version of Home Assistant, like the Docker version for instance, then you'll have to figure out how to install these extra components in a different way that's suitable for your setup. In Home Assistant OS though, we're going to install the File Editor add-on. So installing the File Editor add-on is actually quite straightforward. Just go down to Settings, across to Add-ons, and then the little blue Add-on Store button in the bottom right. And File Editor should be listed amongst the official add-on section here, so I'm just going to click on that. Click on Install. This will take a few seconds, so I'll fast forward through it. Once it's installed, you just have to click on the little Start button there, and you'll also want to tick this box here that says Show in Sidebar. Once it's started, you can access File Editor from the menu on the left-hand side. So if I click on that now, it just opens up by default my configuration.yaml file. If you want to know how to install Emoncms locally, then skip ahead a bit to scenario 2. But right now I'm going to show you scenario 1 using emoncms.org cloud hosting. How do you send your data to Emoncms in the cloud? So you start by visiting emoncms.org, and if you don't have an account, you'll need to register for one. I've already got an account here, so I'm going to log in with that account. Now visit the My Account page and scroll down to make sure that you've got some credits. If you don't have any credits, follow the instructions in here, so these 3 lines here. Go and buy some credits and activate them against your account. Once you've done that, scroll back up to the top of the My Account page, and you need to copy this read-write API key to your clipboard. So I'm just going to do that now. Back over in Home Assistant, you'll need to go to File Editor, and you need to open up your configuration.yaml file. So if you need to find that, you just go to Browse File System, and it's in this Home Assistant folder, and it's here called configuration.yaml. So I click on that, but it's already open here for me. So I'm going to scroll all the way down to the bottom of this file and put some space at the end here. I'm then going to paste in a little bit of configuration to configure the Emoncms history integration. Now you'll notice here that this API key is the one that we got from the Emoncms My Account page. So I've pasted that in here, and the URL needs to be emoncms.org, and don't forget this is HTTPS. Now in this whitelist section, this is where you need to list all of the Home Assistant entities that you want to share with Emoncms. So in this example, I'm sharing my heat pump power, which is from the Shelly EM, total active energy, also from Shelly, and then these ones here are all from ESP Altherma. So we've got a binary sensor, so as it knows when it's doing hot water or heating. We've got flow sensor, which is the litres per minute of how fast the water's going around the system. Inlet water temperature and leaving water temperature, so these are the flow and return temperatures. LW set point main is actually leaving water set point, so this is the set point for the flow temperature. And then I've also added another sensor that I've got for outdoor temperature. So save this file and then go down to Developer Tools, check the configuration, and hopefully it'll show green if you've pasted it in correctly, and then restart. So we're going to go restart Home Assistant and we're going to wait for that to reboot. So once Home Assistant has rebooted, you want to give it a minute or so and then go back over to your Emoncms page, and mine have already started coming in. So if you go to the setup page here and you go to inputs, which is the page I'm already showing, then these entities here are all of the sensors that I've shared from Home Assistant with Emoncms. So this is what you need to see, is inputs listed in Emoncms, and ideally with values against all of them. I'll talk about configuring those feeds in a bit, so jump ahead if you want to get straight into that. Right now though, I'm going to talk you through scenario 2, installing Emoncms locally as a Home Assistant add-on. So let's install Emoncms as an add-on first. We go down to Settings, over to Add-ons, and click on the blue add-on store button again. But this time we need to go up to the top right, to those three little dots, and click on repositories. Now in this add box, we need to paste in the GitHub repository for Emoncms. Now I'll put this down in the description so as you can copy and paste it easily. But once you've pasted it in there, you click on add, and it appears in this list here, and then click on close. Now click on refresh for your browser so as it can update the add-on store, and you should see Emoncms listed here. So click on that, click on install, and then wait a couple of minutes for it to install. Now before you start it, you've got to go up to configuration. There's a couple of things you need to change. So you'll notice the time zone by default is Paris. So you want to change that. I'm going to change mine to London. Once you've changed it to London, just scroll down to the bottom of the first section and click on save. Now notice that there are multiple save buttons, so you've got to click on the save button for the section that you edited. This bottom section called network, you need to now tick the box that says show disabled ports, and this top one here that says 80, we actually want to type in 7080, and we're going to click on save. Now go back over to the info tab, click on show in sidebar and start. Now it will take a couple of minutes for it to start, so you've got to be patient, but once it has started you should be able to click on Emoncms here on the left hand side, and it'll ask you for a username and password. Now this username and password is totally local to Emoncms on your Home Assistant installation, so we're actually going to click on register. I'm going to put in an email address. It doesn't really use this, to be honest, but you've got to type one in anyway, and then I'm going to put a password in. Lots of type in there, and register. Now go over to File Editor and make sure you are editing configuration.yaml. So scroll all the way down to the bottom, make a little bit of space and paste in this configuration, and then click on save. Now go back over to Emoncms and down to My Account, and you need to copy read and write API key to the clipboard. So I've done that now, and then go back over to File Editor, back down to that little bit of config you pasted in, and on the API key section put a space and then paste that API key in and click on save. So all we're really doing that's different this time compared to the cloud version is we're putting in our own local API key. The URL we're using is HTTP, so there's no S on there, so it's not a secure one because it's only communicating locally. Hostname is localhost and the port is 7080 like we configured in the add-on. We then list all of the same sensors that we want to share in Emoncms like we did with the cloud version, so this part is exactly the same. So once that's all in and saved, you need to go to Developer Tools, check your configuration to make sure it's valid, and then restart Home Assistant again. So once it's booted back up, you want to give it a couple of minutes so as all of those entities can start populating in Emoncms, and then you can go over to Emoncms. You want to look on the input section and you should see, yep, just like this, a load of inputs that are all populating in here with their values associated with them. You should now be at a point where you have a list of inputs in Emoncms, whether that's Emoncms installed locally on your own network or Emoncms in the cloud. The next step is to take those inputs and turn them into feeds. So inputs are data streams coming into Emoncms. Feeds take that data, process it and save it so you have a history of data that can be graphed. I'm going to show this process on my local installation of Emoncms, but the process is identical for the cloud version. So we're going to start by creating the easy feeds first. So make sure you're on the Inputs tab, and I'm going to choose sensor.airsourceheatpumppower. I'm going to click on the little spanner icon on the right hand side there. We're going to choose log to feed. We're going to say create new, and then this little field here, I'm going to delete whatever's in there. I'm going to put the word, well, it's difficult to see there because it's short, but heatpump underscore elec, and it's got to be written exactly like this. And I'll show you in a little bit where you find out why that should be written exactly like that, but just trust me for the moment, it needs to be written exactly like this, heatpump underscore elec. Now for the engine, we want to choose Emoncms fixed interval time series, and we're going to choose 60 seconds. Click on add and changed, press to save and close. Now if we go and look over in feeds, we should see this one feed called heatpump underscore elec. Oh, I don't want to do that. It's fixed interval of 60 seconds, and at the moment it's got no data in, but that will start to populate over the next few minutes. Okay, back over to inputs, and we're going to do the energy one next. So if I do this one here, I'm going to log to feed, create new, and this one is heatpump underscore elec underscore kilowatt hours. This one is also fixed and 60 seconds. Add, save and close. Now for this binary sensor, to tell it whether it's running a hot water or a heating cycle, I'm going to click on configure, log to feed, create new, and this one is actually called heatpump underscore DHW. Again, this is going to be fixed of 60 seconds. Oh, what is going on? Have I made a mistake? Oh, I forgot to delete what was in there first. That's my mistake. Always make sure you delete what's in there first and then paste in the correct one, and I should be able to add it. Yep, that's worked. Change and close. Next one, I'm going to take this flow sensor and we're going to create a new one. We're going to log it to feed, delete what is there. I'm not going to make that mistake again. And this one is called heatpump underscore flow rate. It's already filled in fixed for 60 seconds, so I trust that. I'm going to save it. Now we do the return temperature, which is the inlet water temperature. So I'm going to create a new feed, log to feed, delete what's there. This one is heatpump underscore return T with T in capital letter there, and click on add and save. And then the leaving water temperature is the flow temperature. So we're going to create one called heatpump underscore flow T with a capital T, again fixed 60 seconds, and save. And now the target temperature is the set point. So in my case, this is the target temperature for the flow temperature, not the house. So I'm going to delete what's there. Heatpump underscore target T with a capital T, again 60 seconds fixed and saved. And finally, the outdoor temperature is going to be called, let me delete that, outside T with a capital T. So that's every 60 seconds, and save. So you'll notice that I'm missing the heat power and heat energy outputs, and that's because my heat pump doesn't provide that data, so I've got to calculate it. So to calculate it, I'm going to take the leaving water temperature before backup heater, which is my basically the flow temperature, and I'm going to edit that one. So we've already got a log to feed for the flow temperature, but we now need to do some calculations on this. So in this little box here, I'm going to scroll down to choose minus input, and the input we want to minus is the inlet water temperature. So that's this one here, and if I click on add, it'll stick another little line here underneath the log to feed. Now the calculation next needs us to multiply that value by the flow. So we go down to X input or multiply input, and we choose the flow sensor and add that in. And then we need to multiply the whole thing by 70. So calibration, multiply, and we type in 70 and add. And that should give us our heat power output. So we can log that to feed as a new feed, and heat pump underscore heat add. And finally, we want to convert that to energy. So this can actually do an integration calculation and convert it from power to kilowatt hours. So we select that there. We want to delete whatever's in that box. And this feed is called heatpump_heat_kWh for kilowatt hours. Again, it's fixed every 60 seconds, so we add. And now we click on changed, press to save, and closed. If we go on over to our feeds section, we should have a whole bunch of feeds here. You can see even those last two complicated ones are now sitting there at the bottom of the list. So we should have got 10, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's all the feeds there sitting ready to go. Okay, so you have your data feeds all sorted. The next step is to put them to use. Now, Emoncms includes what it calls apps, which are basically dashboards for displaying your data. One of the apps is called My Heatpump, and that's the one we need to configure. Okay, then back over in Emoncms, you want to click on Apps and click on New. Scroll down to find the My Heatpump app, which you can click on there. You can give it a unique name if you want, so I can do that, My Heatpump STTG. Click on Create, and if you've created all of your feeds correctly, everything should just start to work and you get this nice graph appearing. But what you should do is go up to this little spanner icon in the top right hand corner, and if I click on that, you've got all of the configuration here for the whole My Heatpump app. And you can see I told you I'd show you where you get those feed names from. If you create them exactly as they are written here, so heatpump elec kilowatt hours, then it will automatically configure it to work with the app. If you name them something different, then what you'll need to do is choose them from the drop down box, so you have to manually edit them. Now there are some other entities here that I've not added in, so you can add your immersion heater power in there if you want to. If your heat pump does cooling, you can add that sort of data in as well, but I've given you what I think is the basic stuff that you'd need to get this up and running. Now you can enjoy your data in beautiful graph form, either by accessing it locally or in the cloud, depending on how you have configured it. But what about that third scenario where you want it both locally and in the cloud? And what about sharing your data on heatpumpmonitor? Well, let's look at syncing the local data to the cloud first, and for that you need to start by creating an account on emoncms.org and buying some feed credits. Over in Emoncms then, we make sure we're in the setup section and we go down to sync. So we can ignore this error message here. It is actually running, it's just showing that it's not because there's a bit of a problem with the container that's running the add-on, but that's nothing to worry about, it's a known issue. So log in here with your Emoncms credentials. So I'm going to do that now and click on connect. And immediately you should see your list of feeds listed here, and they're all local at the moment. So I'm going to click on select all and then upload selected. Now if I go back over to Emoncms, I'm already signed in on my account here. If I go over to feeds, you'll see that the feeds are immediately populating here. So all of the same feeds that were in Home Assistant are now sitting there in Emoncms. And now all you need to do is go over to apps, create a new app, and pretty much you do the same thing that you did before to create yourself a My Heatpump app, and as long as all the feeds are named correctly, it just automatically starts working. This is the final part of this mammoth tutorial, I promise. I'm now going to show you how to add this system to heatpumpmonitor.org. So you do this bit on emoncms.org. So you go over to your feeds and you select all of your feeds, edit them all, and we want to tick this little box here that says make public and save it. So now you want to go over to the app section and your My Heatpump app. Click on the little spanner icon and we want to tick this Make App Public box. Now you need to open a new tab and you want to visit heatpumpmonitor.org, and you'll need to log in with your Emoncms credentials, which is what I've already done here. So I'm now going to go to My Systems and I'm going to add a new system, and then it'll automatically ask you if you want to pull in your Emoncms dashboard, and it should have, there's my demo one here. It'll fill in a URL for you automatically. Now this bit is a bit of a pain because you've got to do some admin. So I'm just going to fill in my location My heat pump type is an air source. Make and model is a Daikin 6 kilowatt. This is only a demo, so I'm not actually gonna pay too much attention to it because I'm going to delete it afterwards. Design flow temperature, I think it was 50 degrees and it was down to -3, something like that. I don't have hydraulic separation. Hot water method is a cylinder with a coil. That is weekly for the Legionella cycle, and it does use the immersion. Freeze protection, I have got anti-freeze valves. Heat loss at design temperature, I think mine was about 5 kilowatts. Property type is detached. 110-ish for my floor area. Age, the house is about year 2000. Fully insulated. I do not have mid-metering. So remember I said you could get professionally installed heat monitoring and energy monitoring for your heat pump. Well, that's also known as mid-metering, and I don't have that. I'm just using the heat pump's built-in data. So my electric meter is an other electricity meter because I'm using the Shelly. Heat meter is heat pump integration. Includes immersion heater, yeah it does. Primary circulation pump is included in it, yes it is. It's got the controls and it's indoor temperature sensing, and I agree to share this information publicly and click on save. So I think this now has to go through some sort of approval process. I think there's a manual approval that they just double check the data is all okay. But at some point very shortly, this will now appear in the leaderboard on heatpumpmonitor.org. And in fact, yes, if you go and look on the My Systems page, you can see it listed here and it does say waiting for review. So you just need to keep your eye on that and hopefully they will approve that for you very shortly. Anyway, I hope you found this useful. If you did, then please give this video a like and subscribe to my channel for free to see more from me. A massive thank you to my channel members and patrons listed here for supporting the channel. If you'd like to support the channel by becoming a member or a patron, then check out the links down in the description, and in return I'll give you early access to my videos and some bonus content too. Thank you for watching. Goodbye.